All right, so today, oh, now, can you guys see my screen?
Yes.
Yes.
So we're starting marginal analysis. Oh, it reminds me. Right here. All right, so marginal analysis. So before we really do any work right here, the first things first, I just gotta give you some base definitions. So our first definition, our first function is what we call the cost function, or C of x. And the cost function as you suspect right here, is the cost of X number of units. We then have the revenue function, which is the revenue, which is R of X, right? And that is going to be the revenue for X number of units. And of course, we have our profit function, which happens to be your revenue function minus your cost function. And that right there is the and of course, that is simply the profit from selling X number of units. That's why here's your profit function right there. Excuse me. So that's our first class of functions right here. And lead. Our next class of functions is our average function. And so C of X bar is the average cost function. And of course, it's going to be the average cost per unit. C of X is defined, or C bar of X is defined as taking the cost function and dividing it by the number of units. Then you have your average revenue function, R of X bar. And that is your average revenue. Per unit. And of course, your average cost function is equal to your regular revenue function and divided by the number of units that you made.
Could you scroll up for a second, please? Okay, thank you.
So that's how you define your revenue function R. Is your regular revenue function divided by R, and of course you have your average profit function, PX bar. There is that feature, isn't there? There you go. You now have my handwriting a little bit better. I don't know. Average profit function. Again, your P of X bar function is equal to your regular function divided by X, the number of units that you made. You know what? I don't care. My words can float as much as they want. Leave them alone. We have one more class of functions. So hold on. Phone call. Yellow? Oh, 1 second. While you're writing all this stuff down. 1 second. The guy's on his way. The guy's on his way. See you later, bye. He should be here in 20 minutes. See you later, bye.
I get to go, right?
No. Ah, boy. Okay, and then we have a third class of functions. And this one has the derivative. So C prime of X, the derivative of the cost function is called the marginal cost function. It is the cost of one additional unit we take the derivative of the revenue function, we get the marginal revenue function. And that's going to be the revenue of one additional unit. And then we have our marginal profit function. And that's going to be marginal revenue minus marginal cost, or just simply the derivative of the profit function. And that's going to be a marginal profit function. The profit of one additional. I should say approximate. Yeah. All right, so That's the other background that we need. Give me a few minutes to write that down. We all good? I can move forward?
No, not yet.
Oh.
Okay, you can move on.
Right, so everything restarted because they had a power outage, and then other people had a similar problem. Well, what we're going to do is we're going to look at a question that kind of helped us focus on what we're looking at today. A company manufacturers. Yeah, I was about to send you a message on Canvas. That's what would happen in a case like this. But for some reason, my phone wasn't connected to the internet either, so it was just all weird, I guess. I was gonna let you know if I could make it back on or not. You know, these companies manufacturing fuel tanks for years. For the weekly. Excuse me. Excuse me. The weekly revenue for selling X tanks. It's R of X is equal to sorry, excuse me, 80x minus 0.05x squared. All right, so you're going to run through a series of questions. For this tank right here. So question number A, find the cost, find the revenue for selling 400 tanks. Go ahead and put the answer for me in a chat message. Send me a private chat message. Go ahead and work that out and tell me what that answer is. Waiting on group message from everybody. Oh, there's not my thing. Let me ask, does everyone think they know what to do?
Oh, no, I don't really know what I'm doing.
All right, so I'm asking you to do what? I'm asking you to find the revenue, correct? And I'm telling you how many items are being sold. Is there a function that tells you how much revenue you make based upon how many items are sold? The answer is yes. It is the revenue function. So you're gonna have to just take the 400 and plug it into the equation. Okay.
Yes, sir.
So, already been 2 minutes. Ah, no one says anything. So, the revenue for 400 items is equals to 80 multiplied by 400 minus 0.05 times 400. When you work that on your calculator, you should get the answer of 24,000. Questions there? All right, next one. B. Find the average revenue for selling 400 pens. Again, quite simply, the average revenue simply R a bar of 400, which is going to be R of 400 divided by 400. And so that's going to be 24,000 divided by 400, which is equal to 6. The problem that individuals, everyone came across right here is simple. Yes, I can tell you that for 400 items, I'll get, if I sell, I'll get 24,000. And yes, I can tell you the average price that I'll get for each item is $60. But that does not help me make the decision. Should I make 500 tanks? Should I make 800 tanks? Should I make 7,000 tanks? This one value right here and what they had up until this point before calculus, really, they couldn't use that to make decisions. They could figure out the value, but hey, I did my crack accounting class, accounting staff. They did all this good work right here, but what are we to do with all this information we have? And so, step in the marginal function. Find the marginal cost revenue function R prime of x. Just take the derivative of the revenue function. Just like we did on the quiz last week, Thursday, you take the derivatives, you just apply those derivative rules. And that's all you need to get the derivative. Okay. All right. So let me help you out right here. What's the derivative of 80x? Well, the derivative of 80x is simply 80, correct? Because the rule is simple. When you have a single x and you're taking the derivative, you just drop the x. Yeah? What's the derivative of negative 0.05x squared? Anybody knows what that derivative is?
0.04 x.
You have to take this and multiply it by that, right? And then subtract 1 from the power. Yes?
Yes.
And so that will give us negative 0.1 x to the first power. Yes or no, or maybe so. Remember, if I have r of x is equal to 5x to the 10th power, then r prime would simply be 50x to the 9th power. That's your derivative right there. That's what multiply and then subtract 1 from the power. Y'all don't sound like y'all remember. Like y'all looking at me like that was a week ago, man.
I remember.
All right. And so that's it. That's literally it, the marginal cost function. So the marginal revenue function. And the marginal revenue function simply take the revenue function and simply take the derivative of that. The key thing right here is that this right here gives us the optimum level of production occurs when the marginal function equals 0. So before, I could just plug in 400 and tell you that's 24,000 so I'm going to make. Before, I could say the average that I would make from revenue I'd make from each of those was $60. But that doesn't tell me if I'm at the optimum level. That doesn't tell me I am doing my best. I'm making my most revenue that I possibly can. Well, if you want to figure out what the optimum level is, what you need to do is use the marginal function, because the marginal function will point you in the right direction. And so the next thing we need to do is to find the optimum level number of, what they call those things again? And so the next question is find the optimum level or optimum number of tanks that we should sell. And so all that requires is for us to simply take the marginal revenue function and simply set that equal to 0. And the optimum level is found when you set the marginal function to 0. It's a two-step equation. Subtract 80 from both sides. Negative 0.1x is equal to negative 80. Divide by negative 0.1. Divide by negative 0.1. And then I get that x is equals to 8. And so selling, when I say selling, selling 800 units will be the optimum level or the most revenue that this company can make. Okay, and let's test that out. A, B, C, D, E. So find the revenue. From selling 795 tanks, 800 tanks, and it's 810 tanks. So just like before, earlier on, I want you to find the revenue for selling 400 tanks. Now, I want the revenue for selling 795, 800, and 810 tanks. All right, so the answers That's not the right thing. Oh man. All right, so the numbers you had to plug in was 795. You had to plug in 800, and you had to plug in 810. The claim was 800 based upon the calculation was the maximum revenue. And so we were kind of looking at revenues around that spot right here. And so 795, so this is equals to 795 multiplied by 80 minus 0.05. Oh, who's calling? Negative 0.5. Negative 0.5 star, open parentheses, 789 squared. And so this is what you should have gotten for the first one, 31,998.75. For the next one, should have done 32,000. And for the next one, should have gotten 31,995. And so what you saw happens right here was that the revenue increased when you went from 795 to 800, but then after 800, the revenue decreased. And so what we're seeing right here is that 800 is going to be the maximum, i.e. the optimum revenue output for our company. Again, we can see this over here. If I switch to this thing right here, and let me zoom out, take it all the way up to 800, so I gotta zoom out a lot. So I can just change this axis now. I just don't remember how. Oh, anyway. Come on. So if you 24,000. So if you see that this is the graph of the function right here, you can see that the function has a maximum revenue. That's maximum revenue. So you create a point, you put that point right here at the top of the maximum revenue. Oh, I missed. Well, you can see that it's a little bit off, but the maximum revenue right here will be at 800. That's less bit. I'm off by the maximum revenue is going to be $32,000. Anything different, would result in us having a revenue that's smaller because we're not at the peak of the function. I'm trying to change the zoom, but that's it. So, any questions there? Anybody else? Ah, cool. And so when you plug in all of those values right here, I gotta go back to my screen. And when you plug in all those values right here, this right here will give us the largest revenue, i.e. this right here will give us the optimum level, the optimum amount of revenue that we get from the vehicle. All right. The derivative, or the reason why the derivative works is for an interesting reason. If you look at the definition right here, the derivative gives us the approximate. The derivative gives us the approximate cost of the next unit or revenue from the next unit. Approximate the revenue of the 401st tank. The derivative gives us the amount we will get from the next unit. So in this case, right here, since we're talking about revenue, if I use the derivative and I plug into the derivative, that'll give me the revenue from the next tank. So if I go R prime of 400, 80 minus 0.1 multiplied by 400, it gives me a value of, it gives me a value of $40. And what that means is that if I make one more tank, so if I make, instead of making 400, I make 401 tanks, instead of making 400, I make 401 tanks. My revenue will increase by approximately $40. And the power of the derivative right here is that it tells you what will happen next. Right? It gives you a look into the future. And so it's literally saying, look, you can, if you sell more tanks, you will make more money, i.e. you bring in more revenue, okay? And so what happens is, if I say, okay, well, let's do 600 instead. Let's make 600 tanks. So that's 80 minus 0.1 times 600. It gives me an answer of 20. And so if I'm making 600 tanks, if I wanted to make one more, I'll make more money. I will get $20 more. But look at what happens at 800. 80 minus 0.1 times 800. This gives me an answer of 0. And so what that tells me is that if I make one more tank, I will not make any more money from that tank. And at that point, does it make economic sense to make another tank if I am literally not going to make any more money from it? And so that right here is a rationale for stopping at 800. If I make more than 800, it's not going to happen. And in fact, for example, if I try to make 1,200 tanks, I'll actually make negative $40. My revenue will actually go down. I'd actually lose money on that tank. If I make that many tanks, I'll actually have less cost per unit. If I will go ahead and go past the 800 unit level. And so therefore, you can see that the whole point of the marginal function is that it gives us that look into the future, and that therefore allows us to make the decision on how best to proceed when it comes to understanding our manufacturing costs. Questions there? Comments? All right. And just to show you why we say approximate, see right here it says, at the top right here it says approximate the revenue. The reason why we say approximate is because the derivative is always off by just a little bit. If I ask you to find the exact cost of the 401st unit. So if I come up here and see right here, this is saying the approximate is going to give me $40 more. If I want to find the exact cost of the 401st unit, I need to find the revenue of making 401 units and then subtract out the revenue for making 400 units. And that should give me the money I make on the last unit, correct? This is how much I make for making 400. This is how much I make for making 401. So if I subtract them, that will leave me with how much I make for, that will leave me with how much revenue I make for the last tank, the 401st tank. So this right here is 24 by my calculations, 0.3995. And this we already calculated was 24.23. And so that gives me an exact of 395. They can see that the derivative was off by 5 cents. Questions there? Comments? Queries? So we move to the next section right here, and the next section right here is called the constant, E, and continuous compounding. Move on to the next section, unless I have any questions. You have any questions? No, you got no question? The number E, or Euler's number, a German mathematician, is E is equals to 2.71828. The number E is an irrational number. Like the number pi, it has an infinite number of digits, and so it goes on forever. The number E goes by the name, the natural number, because it governs many rules that occur in nature.
Can you scroll up a little bit, please?
That's good enough.
Yeah, that's fine. Thank you.
And the actual definition for E is the limit as n goes to infinity of 1 plus 1 over n raised to the nth power. So if you want to figure out the value of E yourself, you plug in n equals 1, then you plug in n equals 100, then you plug in n equals 1,000, then plug in n equals 10,000, and then 10 million. And the larger the number you plug in, the more accurate the value you get for E. Limit to infinity means I get numbers that get bigger and bigger and bigger and bigger. Whoop. Whoop. So the place we want to use the constant E is when we're talking about continuous compounding. Continuous compounding is a natural process, i.e. E is a natural number, a process that occurs in nature. Whenever we're talking about continuous compounding, we're talking about the fastest rate at which anything can grow. So if you're looking at a tree and the number of leaves that the tree can put on, the fastest rate that that tree can put on leaves is going to be governed by the number E. You're looking at your money in the bank, and the fastest way that money in your bank can grow, that would be, again, put on by the number E. If you're looking at the, what else goes quickly? Population, rabbits. If you're looking at animals, the fastest that the population can grow, fish, krill, all that stuff right here in the water, the fastest that that can grow, all of that is set by the value E. We call those processes continuous compounding. Continuous compounding is the fastest rate at which money can grow. Again, you can replace money with anything in this world. For money in particular, the amount that you have is equals to the amount you invest multiplied by E raised to the RT formula. Hopefully you've seen this formula before when you're doing college algebra. A is the amount you will have in the future or you expect to receive. It's often called the future value. For you accounting people out there, and what's this? I think economics people do this too. P is your investment, often called the principal. Or current amount in you have in your bank account. R is the annualized interest rate. And of course, T is the time you need. And hopefully you remember all of this from CA, college algebra, the greatest class known to man. And really and truly, these questions are just pick and pull. So you just pick the values that you need and you just plug them in. Y'all got it done? I can try out a question or two.
Yes.
Very much. So, question. If you invest, you're a good person, you're saving up your money, $1,000 at 12%, how much will you have accumulated? My handwriting's dying. Revive, revive. After 4 years, assuming continuous compounding. Well, when we're doing these questions, we first have to see what we have. The amount, we don't know, so that's what we're trying to find. The principal is 1,000. The annualized interest rate, you don't use 12, you use 0.12. Remember, 12% means 12 out of 100. 12 out of 100 is 0.12. And the time is 4 years. And you just plug that into the formula. So A is going to be 1,000 E raised to the 0.12 multiplied by 4. And so that's going to be 1,000 E raised to the 0.48. When you get a chance, you need to go back and double check this and make sure it gets into your calculator, gives you the right answer. But the right answer is 1607. If you don't get this answer, let me know so I can help you figure out why your calculator is being made to. Okay. So what does that number mean? 1607. Well, it means that you received 16,607 minus your initial investment of $1,000. It means you received $616.07 of interest. So by just leaving that money in the bank, you added yourself $600 more cash. You know how they say in the business, cash. You're like cash, right? So in 4 years, it took you, you went from 1,000 to $1,600 approximately right here. A question that often comes up, well, how long will it take you to double your money? It took me 4 years to make $600. How long will it take me to make another $1,000? But before I answer that question, any questions so far on just plugging it into your calculator?
Yes.
But the other question I was going to ask was, under the same scenario right here, how long will it take to double your money? That's the question, the other question I want to get to. So I know my investment is still $1,000 because that's what we have right here. I know the interest rate is still 12%. That's a pretty good interest rate, actually. Your interest rate is 12%. But the question is asking us how long, and so the time is an unknown value, and so we have to work to find out the time. The question said how long, so you have to work to find out the time that works for this equation. How come I cannot find it? So I'm gonna have to do something else. Right, and so, but the question says, I'm doubling my money. If I start with $1,000, that means I should have $2,000 available. And so that's what I plug into my equation. So that's going to be 2,000 is equals to 1,000 e raised to the 0.12 multiplied by t. And we have to work to figure out what that t is going to be. First step, divide by 1,000. And so 2 is equals to e to the 0.12 t. Now we have to remember that the opposite of e is ln, or the inverse function. Is ln x. And so what I do is I take ln x on both sides. So you take, that's not how you spell take, oh my goodness. On both sides. And so that will leave me with ln of 2 is equal to ln of e to 0.12 t. Now, ln and e are inverse functions, and so they will cancel each other out. And so that will leave me with ln 2 is equal to 0.12 t. And then all I have to do is simply divide by 0.12. And in so doing, I will get that t is equals to, again, you have to work this out on your handy dandy calculator, but t will be equals to approximately 5.788. And so what that means right here is that it takes approximately 6 years to double your money if you're investing at 12.5%. Questions there? Comments? Queries? The interesting thing right here, and the knowledge that you really need to gain from this problem in particular, is that that time right here is independent of the amount of money you start with. And what that means right here is that if I only had 10 bucks instead of 1,000, if I only had 10 bucks, I'm trying to double it. So A is equals to 20. My initial amount is 10. My rate is still 0.12, and the time I'm trying to figure out. So that's 20 is equals to 10. E raised to 0.12 t. Divide by 10, divide by 10. That leaves me with 2 is equals to e to 0.12 t. And that's exactly the same as this line right here. So for someone with $10 and they want to put it in the bank and save it until it gets to 20 bucks, ln 2, ln e to 0.12 t. ln2 0.12t divided by 0.12. It turns out that the time is exactly the same. And that's what I mean by it's independent. And so that has two consequences for us. The first consequence is simply that it is good to be rich. Because literally for the same amount of time, one person earned $10 to go from here to here, to go from here to here. They made $10 in 5.7278 years. While the other person went from here to here, they earned $1,000 in that same 5 years. Of course, if you had $1 million, you'd earn $1 million in 5 and 7 years. If you had $1 billion, you'd earn $1 billion in that same period of time. And so the point right here is simply that because your money is working for you, the more money you have working for you, the better off you will be, because that's less work you have to do yourself, right? That's the first thing right here. The second thing, which obviously good to rich doesn't apply to most of us. The second thing, and the more important thing, is your time horizon. What's the horizon? I don't know. Your time horizon. Look at this little table right here. Time, investment. Again, we're assuming 6 years to double your money. If right now you put up $10,000 right now, in 6 years, that money would double. In another 6 years, that money would double. In another 6 years, that money will double. Yes, see what I'm doing right here? 18 plus 6 is 24. That money will double. Another 6 years, that's 30. That's 320,000. That money will double. Another 6 years, that's $640,000. $640,000. And of course, one more for 42 years right here. That's going to give you $1,280,000, right? So why am I writing all of this down? Well, it turns out that if you put up a small amount of money right now and you get a good interest rate on that money, most of you are somewhere around 20 years of age. If you add in that $42 right here, that'll get us to 62 years of age. And we know most of people plan to retire around 65 years of age. If you put that money up now, literally, that will be all the money that you will need to save for retirement. You can get to all of your retirement goals right now. And so that means all the money that you get from here on out, you can just do whatever you want to do once you put up that first amount of money, and you simply sit it down and let it grow. And of course, you know how retirement works, right? If you have your $128 million and you're getting 5% on that, that's approximately, what's 5% on this? 128 0.205. That's $76,800. This money every year will give you this amount in interest. At a more conservative investment, and so literally every single year for the rest of your life, you will get $76,000 odd from your retirement fund. Y'all know that's what retirement is, right? You can retire once you have enough money, such that that money working for you will produce enough money so you don't have to work yourself. Right, y'all know that's what retirement is, right? Right. And so the point is, any and all of you technically can become a millionaire today if you had enough money to simply put it up. And of course, if you have, say, 2 kids after you move on and you take that money, you split in half, and then both of them put that money up and let that money grow. By the time they get to retirement, they might have what, 10 million, $20 million in the bank. Of course, you gotta teach them to do the right thing, But the point is right here is that you can build that legacy, that change money, that money that makes people's lives change, if you make some smart decisions now. Yeah, I know what you're thinking. I ain't got no $10,000. Well, it happens that you don't need all of the $10,000 at once. You can put in a small amount of money every month up, and over time, that money will grow to this money. But the point is, you just need to start putting money away now, because your most valuable asset that you have right now is this. Horizon. But your most valuable asset that you have right now is time. Simply putting your money down and letting it grow will get you basically any amount of money that you really want, if you just simply have enough time. Questions there? Yeah, and so literally, this is one of those secrets in life that for some reason most people don't learn or never hear about or whatever, and you just go through life just struggling, trying to put food on the table, and just struggle your whole life when if you make some good decisions early, you are not required to do that. But anyways, I digress. Any questions?